Hello again. I'll be explaining how to solve for a moment of force in this video. Let us consider a numerical to understand how to solve for a moment of body analytically. Now, consider a simple beam floating in space. Now, if we apply a force in any of the directions, the beam is going to move in that direction in a translational motion. That's what scientists love about space. No other undesirable forces to change the course of motion. But when on Earth, there will always be one force which would consistently act on any of the objects. Yes, the weight force. Although this weight force is distributed uniformly all over the body, we generally consider the total weight to be acting on its centroid or its center of mass to ease our calculations. So, this weight force will always pull the beam to move in a downward direction towards the center of the Earth. Now assume that this beam AB is pinned at this point A. This pivot point is going to be the reason which is not going to let the beam to move in a linear motion. This beam would now instead rotate about this point A. The moment produced about this point A will be equal to its weight times the perpendicular distance from the considered point of rotation. The weight is equal to mass into gravitational acceleration, as you all know, and the perpendicular distance will be equal to half of the length of the beam as it's acting on the centroid of the beam. This is why the beam would rotate about the point instead of moving linearly. If we consider an example where the weight force of the homogeneous beam is equal to 20 newtons and the length of the beam is 4 meters, and again it's pivoted on the same point A. Now the condition is to apply a force on this beam at different points and try to reverse the moment produced due to weight. But there is a limit to the force you can apply, which is 15 newtons. Let's call the distance from the pivot point as x. The moment will be because of the two forces, push force F and the weight. Now to calculate the moment, mathematical formula will be force times distance, but at the same time you also have to consider direction. By direction, what we mean is in which direction will the force tend to rotate the beam. There are two possibilities, clockwise or anti-clockwise. To make our calculations easier, let us say that clockwise rotation is positive and anti-clockwise is negative. The equation of the moment produced will be force times its distance x and weight times 2 meters, which is half of length AB. But we know that weight will tend to rotate the rod in clockwise direction and the force will tend to rotate it in anti-clockwise direction. So the moment of weight will be positive according to our notation, as the motion it causes is clockwise. Now let's place the given force very close to the pivot, say at half meters. When the 50 Newton force is placed at 0.5 meters, the total moment produced is 32.5 Newton meter. Now for the second case, let's place this same force at 4 meters from A or the other end B. Now if you calculate the moment using the same equation and input the values, you would get a total value of minus 20 Newton meters. The minus sign indicates that the motion for this case would be in an anti-clockwise direction when the distance of force is 4 meters from point A. From this answer you can understand that how with the same force you can change the moment and its direction. I hope you have understood the basics of how to solve for a moment. If you have any queries, comment in the section below. Have a nice day.